Okay, let's see another concept of a limit. Once it is applying on a slope of normal line, that is related to the average velocity. And it's very simple. In our previous classes we already studied about this concept, that it is kind of some final distance minus initial distance, final time minus initial time is what? Rise over run. Okay, following the formulae of slope. Okay, and it is what? Basically it is telling us about the average. Average result, okay? This is the average velocity, and of course we can say that d our, okay, this is representing average velocity of a car, of a bike, or whatsoever the thing which is moving on a road. We can say that vehicle is moving on a road having average velocity. With the help of digital devices or speedometer, it can be observed. But once we want to check out the velocity of any vehicle at some jump or some sharp turn, what we will do? We will apply limit. Now we are stopping the car, but we want to analyze the velocity at an instant, and it is also known as instantaneous velocity. Instantaneous velocity. For this purpose, what we are doing, we are basically applying limit, that change in time is almost approaches to zero. That in some short span of time we want to observe its velocity, then this average velocity will be equivalent to instantaneous velocity when time approaching to zero. So this is very beautiful example of a limit, that it does not mean that totally car should be stopped, but at particular instant its velocity can be observed. So here we can see in a figure that the needle, is variation of a needle. You can say that is telling somehow. Here you can see the reddish somewhere variation. It is telling the velocity of a vehicle at an instant. Somewhere speed is touching to 120 mile per hour, or somewhere it is touching to the 20 mile per hour on a shady roads, or where the roads are not in form of a smooth bed. At that moment the instantaneous velocity is fluctuating in between 20 or 40, but on a motorway, on a clean road, you can say it is touching velocity is variation of a velocity is needle is moving in between 100 or 120 somewhere. So what is this 100 and 120? Basically a velocity at an instant, at that moment. That once delta t approaches to zero, and this is the concept of limit. And of course it is some between some point, interval L minus epsilon, or you can say that A constant and union A L plus epsilon. And this A is representing sometime 120, near to 120 or 119 or somewhere 118, or somewhere it is representing here like this. Somewhere it is representing 135 that is the instantaneous. Somewhere it is telling the 136, near to 139. So, but it's union, interval, this interval limit interval is existing. But as I told you people, the two different concepts, and that left hand limit equivalent to the right hand limit stability concept, and this is the information of a limit is also telling the information at an instant. So then in case a time interval approaches to 0 but not exactly to 0, car is not stopping on a motorway or at such a high speed 120. So it is one concept of it. Slope of a tangent line for a function y equal to 1 over x, slope of a tangent line, or you can say that y is a function of fx. We can also represent it like f of x into 1 over x, and in previous calculation we observed that taking value of this function once x approaches to 0, it gives us some derivative rate of change of this equal to minus 1 over x square. Okay, this was and what is this? Basically this is a slope. This is a slope m of tangent line. Slope of tangent line. So slope of tangent line is representing with this. Okay, remember this. Okay, we will use it in our further concept. There is a question. Question is very simple, that find area of triangle enclosed by axis, okay, represented, that is the sum of axes and tangent to function y equal to 1 over x. The graph of this is a question, okay. The graph of this is very simple. As I already explained to you, the graph at, if we are substituting the random value from -3 to +3 at the 0, it will at some distance from the origin. So they are saying they find area of this one, area of a triangle enclosed by axes, and these are the axes. So suppose this one is the known point, this one is the known point, Assalamu alaikum. Hi everyone. Today we will start from our last lecture. In our last lecture we talked about an idea of limit, that if x approaches to 0, then the function f of x, that is the range, will approach to some required or some stable position, and this stable position or location is representing with L. Usually this is a mathematical notion which is used in our textbook, so I'm starting it from right here. Basically x is a position which is not exactly equal to 0. If I say a little bit further about little more about it, we can say some epsilon, very small value, but this small value should be greater than 0. This sign is representing are known as epsilon in mathematical notion, and if this epsilon is lying or existing in some open interval, in this open interval you can say that some fixed point x0 and some next point x1, somewhere in between these two positions, this epsilon is existing in between these two positions, and this is what open interval. As I told you in previous lecture, on the x-axis of course, and basically this point is you can say that containing some epsilon between them. So the definition of limit according to the left hand side and right hand side is going with a concept that the function is strictly increasing from this L is some kind of a stable position or some the final verdict, but less than this negligible value or but little greater than 0 should be subtracted from this stable position, and of course the function our range or output definitely should be greater than this, as well as this function must be strictly, if there is no equal sign, then we can say strictly decreasing, that it should definitely be decreasing or lower than the value of some stable position along with addition of epsilon. And we can say in this situation we say that this function is confined. Confined is using concept that is existing between this point somewhere, and of course I am talking about x. X is existing between x0 and x1 somewhere, that this function f of x is confined between these two positions, and so on the open interval, and this open interval further we can write this expression like L minus epsilon, L plus epsilon. So this is a precise definition of this function, that the stability of a function, that left hand limit and the right hand limit once equal, these both sides are equal to one another, then we can say limit exists, or we can say that seesaw is for example, this is some seesaw, the two children of the same weight are standing at in an equilibrium position. Once left hand limit is equivalent to the right hand limit, then we can say that function is stable, or we can say limit exists. So the precise, this is open interval, x is of course not exactly, okay, we cannot say that the weight of the two children are exactly equal to one another, but somehow almost near to one another. So this is the definition of limit, and graphically we can say that suppose the along y-axis and x-axis we have a function f of x along some point x, along x on x-axis. You can say that this one is x1 and here this one is x0. Of course, there is some distance covered. So we can say that this function is following this path or lying at this position. So what we can say that it is the exact, or you can say that the original function for stability it should be there, but the interval should be like this. This yellow line is representing of some kind if greater than L plus epsilon is lower than this one, representing with this. So this function is confined by the lower bound of the limit. This is the lower bound and this is the upper bound, and the stability is this, the gap between, okay, this one and upper and lower should be almost near to the one another, or we can say left hand side limit equivalent to the, almost equivalent to the right hand side limit. And this L is nothing, it can be a constant value, okay. Somewhere in a book it is representing L equal to some A or some numeric value, for example L equal to 2 or 3, or maybe in terms of a seesaw okay, swing or child weight, so constant value 10 kilogram or 15 kilogram. In solving our mathematical problems, the value of a limit is equal to 12, 10, not exactly 0. But what happened? Well, it is not important, always it should be 0, but that the stability, okay, balance, equilibrium position, left hand side equivalent to the right hand side. Therefore, it is not always correct that limit must be equivalent to 0. Somewhere we are observing that limit approaches to 10, so limit exists or not. Limit, if not stable, equilibrium position does not exist on the both sides, then we say limit does not exist. If equilibrium position is attained, system is stable, then we say limit limit does exist. If not, then we can say limit does not exist. So in this case, the interval, open interval can be like this: L minus epsilon, or with some, okay, constant value, for example A union, or you can say that A L plus epsilon. The reason is this: suppose the A okay, limit x approaches to 0. Suppose A is 0, or maybe suppose A equal to 10. It does not mean that it should exactly 10. It is all approximation. It's nearly to 10. So this is in the open interval. A should not be included. Okay, as we know that in the closed interval A is open. This value should be included, but in open interval A does not include. So union of this, that the everything, okay, maybe variation 9.9 kilogram on one side and 9.8 kilogram on the other side, and it looks like at least some stability. So we can say that swing seesaw is stable at some position, our system is balanced. Even we are observing the building in Dubai, Burj Khalifa. Why it is not falling? Because the limit does exist. Okay, system is stable till so high. So mathematically, being a computing student, you should first define a algorithm and then test this algorithm with the help of simulation. And if limit exists or stability, okay, error round off, error work is providing you the same answer, though you can say that it will work up to this extent. Once the limit, okay, both sides are not stable, not equal to one another, you should tell that don't construct this building, it will fall down. It is not a stable building. Okay, so being a computing student, you should know how to tackle the real world problem amicably and sensibly. But sometimes it has also happened. You people are observing a function